Chinese have announced that they're going to go to the moon. In fact, they will probably beat the United States.
There are actually high concentration of ice water in the permanently shadow regions of the lunar poles.
The Apollo 11 mission, which took place on July 20, 1969, stands as an extraordinary accomplishment in human history. On that remarkable day, approximately 530 million viewers witnessed the live broadcast of US astronauts Neil Armstrong and Buzz Aldrin taking their first steps on the moon. Subsequently, Armstrong, Aldrin and their crewmate Collins safely returned to Earth and landed in the Pacific Ocean. However, within a few years, skeptics emerged, claiming that the giant leap for mankind was a fabricated event. Conspiracy theories suggesting that the US government staged the moon landing to outpace the Soviet Union in the space race gained popularity in the mid-1970s. Despite these claims, the moon landing was indeed a genuine achievement, and multiple nations are currently engaged in a race to explore its mysteries. Recent lunar missions have uncovered astonishing revelations about Earth's satellite, and renowned physicist Michio Kaku unveils the alarming truth about the moon. What has Kaku revealed now, and what it means for the moon exploration? Let's find out. The Apollo 11 moon landing in July 1969 was a huge feat of human endeavour, engineering and science. It was a moment that the world had been waiting for. Following Apollo 11, there were 6 additional trips to the moon, 5 of which were successful landings. In total, 12 individuals walked on the lunar surface. However, in 1970, future Apollo missions were cancelled indefinitely due to financial reasons. Ironically, the cost of reaching the moon was incredibly high. Nevertheless, recent advancements have made a lunar mission inevitable and relatively easy. Notably, Michio Kaku has commented on the various endeavours to recreate history, and China has recently sent a robotic spacecraft to the moon to collect lunar samples and bring them back to Earth. Kaku congratulated China on this achievement, noting that they have become the 3rd country to accomplish this, following the United States and the Soviet Union. It seems as though China is both following in the footsteps of the US and making notable progress by taking shortcuts. Furthermore, a recent discovery made by China has puzzled many and raised questions about the existence of life on the moon. In a captivating new study highlighted by Kaku, scientists have confirmed the presence of water trapped inside small glass beads scattered across the lunar surface. China's Chang'e 5 lander meticulously collected these water-containing beads during a successful mission of lunar exploration. This significant discovery, published in the Nature Geoscience journal, provides insights into the characteristics of lunar water and its implications for future space exploration. A team of researchers thoroughly examined 117 individual spherical glass beads that were carefully selected from a lunar soil sample obtained by the robotic arm of the Chang'e 5 lander. By utilizing advanced techniques like field emission scanning electron microscopy, electron probe microanalyzer, and Raman spectroscopy, scientists were able to validate the existence of water within these beads. Tiny glass spherules could be abundant enough to hold as much as 330 billion tons, 300 billion metric tons of water spread across the surface of the moon. These spherules, known as impact glasses or microtectites, are formed when meteorites collide with the moon at high speeds, causing fragments of lunar crust to be ejected above the lunar surface. Within these plumes, silicate materials that are heated to molten temperatures due to the impact's force combine and solidify into tiny glass beads, which are scattered like small particles across the surrounding landscape. During a podcast, Kaku mentioned that the moon's soil contains oxygen, indicating that the glass beads also contain oxygen. When these molten spheres are bombarded by ionized hydrogen atoms, protons, from the solar wind, the oxygen within the spheres reacts and forms water, which is then trapped inside the silicate capsules. Over time, some of these beads become buried under lunar dust particles, known as regolith, and are effectively trapped underground, still containing the water within. The researchers explained that at suitable temperatures, some of these beads release the water into the moon's atmosphere and onto its surface. This process acts as a reservoir that gradually replenishes over time. This discovery suggests that these glass spheres could serve as an excellent source of water as well as hydrogen and oxygen for space agencies like NASA and the China National Space Administration, CNSA, that have plans to establish moon bases. The CNSA aims to complete its moon base project by 2029. Study co-author Sen Hu, a planetary geologist at the Chinese Academy of Sciences Institute of Geology and Geophysics, explained the procedure for extracting water from impact glass beads for future lunar exploration. First, the beads need to be collected, then heated in an oven to boil and release the water vapor. Finally, the condensed water can be obtained in liquid form. Hugh also highlighted another advantage of impact glass beads, which is their widespread presence in lunar soils. They are found across the Moon's equator to polar regions from east to west, uniformly distributed on a global scale. Scientists have dedicated extensive research to examining the existence of water on the Moon, aiming to comprehend its origin, distribution, and evolution within the lunar regolith. This recent discovery greatly contributes to our expanding knowledge of lunar water, which holds significant implications for future explorations of the Moon's surface and our understanding of water reservoirs on airless celestial bodies within the solar system. One factor that hindered the findings of water on the Moon was the substantial gap between surface missions. Prior to the Chang'e 5 mission, the most recent soft landing on the lunar surface took place in 1976 with the Soviet Union's Luna 24 mission, resulting in a lengthy interval of 37 years. However, the future appears promising, with initiatives such as NASA's Commercial Lunar Payload Services program, which intends to carry out a series of upcoming missions. Among these missions, the Volatiles Investigating Polar Exploration Rover, Viper, is scheduled to land near the Moon's south pole in late 2023 to search for ice. Interestingly, while their quest for definitive evidence of ice may take some time, American scientists have also made a significant water-related discovery. Previously, it was believed that water could only exist in the shadowed regions of the Moon. However, thanks to NASA's Stratospheric Observatory for Infrared Astronomy, SOFIA, water has been detected in the sunlit areas of the Moon for the first time. This revelation suggests that water may be spread throughout the entire lunar surface, just as Sen Hu suggested in his study. SOFIA, an impressive aircraft equipped with a powerful infrared telescope, allows for unobstructed observation of celestial objects by bypassing Earth's atmospheric interference. When they turned their attention towards the Moon, their focus was on Clavius Crater, the second largest crater visible from Earth, situated in the Moon's southern hemisphere. This remarkable crater measures 231 kilometers in width and 3.5 kilometers in depth. What captured their interest was the detection of water molecules within this crater, further enhancing our knowledge of water distribution on the Moon. It is safe to say that our understanding of the Moon is continually evolving and undergoing changes. During the initial Apollo missions, when astronauts first set foot on the lunar surface, it was widely believed that the Moon lacked any water. However, intriguingly, the rocks brought back from those missions hinted at the presence of water. Unfortunately, at that time, these findings were disregarded due to concerns of potential contamination. Now, with this recent revelation, we have come full circle and realized that water does indeed exist on our celestial neighbor. This discovery revolutionizes our comprehension of the Moon's composition and its potential to support future explorations. In addition, another team of Chinese scientists recently made a remarkable finding as they came across a new lunar mineral called Chang'e Y among the samples obtained during the mission. This discovery contributes to our knowledge of Earth's satellites and represents a noteworthy milestone in lunar exploration. Chang'e is a unique crystal of a novel phosphate mineral, making it the sixth mineral ever obtained from the Moon by humanity and the first lunar mineral discovered by China. This accomplishment places China as the third country, following the United States and Russia, to have discovered a lunar mineral in the past 4 decades. Chemically, it is associated with the more common phosphate mineral merillite found in lunar and meteorite samples. Scientists have classified it as a member of a subgroup that is found in meteorites as well as on the Moon. Furthermore, according to Michio Kaku, this crystal harbors a secret component that has the potential to revolutionize our energy requirements. This special ingredient is helium-3, and researchers believe it could hold the key to fueling advanced nuclear fusion reactors. However, there is a caveat to this fascinating discovery. Helium-3 is extremely scarce on Earth, whereas it appears to be abundant on the Moon. Kaku hinted at how rare resources like this can drive an inevitable race to tap into the Moon's abundant resources. Although it is too early to determine the financial value of this lunar fuel source, one thing is certain: extracting the crystals required to power fusion reactors won't be an easy or inexpensive endeavour. The logistics involved in extracting and transporting them from the Moon present a significant challenge. For years, scientists have been captivated by helium-3 and its potential to unlock the secrets of nuclear fusion. Fusion, the process that fuels stars, holds the promise of providing limitless clean energy for humanity. However, we have yet to develop a fusion reactor capable of generating sufficient energy to initiate this incredible process. Furthermore, Kaku discussed the significance of considering the military aspects of space exploration when discussing the Moon. While we may not witness a total space race like in the past, the military implications of space exploration cannot be ignored. Powerful nations such as Russia and China are currently developing hypersonic drones, which are increasingly being favoured as weapons. It is worth noting that reaching the Moon itself does not hold significant military value, as it takes only a few days to get there. However, the ongoing arms race on Earth, particularly the advancement of hypersonic drones, raises concerns. This is where the establishment of the US Space Force comes into play. Initially, some people may not have taken it seriously, but it serves a practical purpose. With a substantial stake in outer space, including control over more than 50% of satellites, protecting vital assets like the economy and telecommunications is crucial. However, the aim is to prevent an uncontrolled escalation of an arms race, which would be detrimental. Kaku also highlighted lesser-known efforts taking place within the United States to explore the Moon. The involvement of visionaries like Elon Musk and Jeff Bezos is propelling the field of space exploration forward. Musk envisions a future where humans become a multi-planet species, striving for the colonization of other planets. On the other hand, Bezos envisions Earth as a preserved celestial park, while moving heavy industries and pollution to outer space. Their engagement has revitalized interest in space exploration, and there is a possibility that one day regular tourists may visit the Moon. Now let's hear your thoughts in the comments below.